In the last video, we covered the introductory basics on angles. In this video, we'll be going over how angles relate to parallel lines, and at the end, we're proving why the sum of the interior angle measures of a triangle is equal to 180 degrees. Now, there is this postulate given right here up on the top, and it's actually taken right out of an AOPS textbook, so credits to them for this definition. So it says, given any straight line and a point not on the line, there is exactly one straight line that passes through the point and never meets the first line. Now, what does this actually mean? Well, here you see that I've already drawn a line, A, and a point, B. Now we see very clearly that point B is not on line A. So, also line A is a straight line, as it says over here. And B is the point that is not on the line. So they say there is exactly one straight line that passes through the point, which is B, and never meets the first line. So what they're saying basically is that there's only one line that can cut through B. Oops, my apologies, because this does not actually cut through B. Let's just make this a little bit bigger. So there is only one line that can cut through B that will be parallel to line A. Okay, so that was just a little bit about parallel lines. So just get rid of all of that and let us redraw the two parallel lines and actually one more line that will intersect both of the parallel lines A and B. And let's call this intersecting line, line C. Now, we see that there's several angles here that have been formed. We have angle A, angle B, angle C, angle D, and also angle E, F, G, and H. Now, we learned in the past video, in angles part 1, that opposite angles are congruent to each other. Now, if we were to measure angle A, quite literally just measure it, we can assume, or rather, let us assume that angle A, the measure of angle A, is equal to 60 degrees. Let's keep that in mind. So if this is 60 degrees, then we know that opposite or vertical angles are congruent. So we also have that angle C is equal to 60 degrees. Now, we know that a straight line also has a straight angle, which is equal to 180 degrees. So if we do some math to find angle B, we would do 180 minus 60, which will give us 120, and thus angle B will be 120 degrees. Now, by the same vertical angle rule, we have that angle D is equal to 120 degrees as well. Now, this next part is a little intuitive. By just looking at the picture, you can kind of see that it appears to be that E, F, G, H are just the same as A, B, C, D. And you would be correct to assume that, but we would have to measure angle E again, and it would actually always give us 60 degrees, as long as line C intersects parallel lines A and B, and as long as A and E are in the same relative positions. So, by the same logic we did here, we have that G is equal to 60, F is equal to 120, and H is equal to 120 as well. So what does this give us? What can we conclude from this? Well, we see that the measure, or perhaps I should make this a little more neat. The measure of angle A is equal to the measure of angle E. The measure of angle E is also equal to the measure of angle G. Now, we could continue to this, but at the end, we see that measure A is equal to measure E is equal to measure G is equal to measure C. So essentially we have that these angles are congruent. Now similarly, we could say the same about the remaining angles. Measure D is equal to measure H, which is also equal to measure F, which is equal to measure B. Now this is a very important concept right here. And we'll label this congruent angles with 2 dots instead of 1 to distinguish between the measures or angles. All right. Now that we know this, let's clear all of this, and let's start to prove why the sum of the interior angles of a triangle is equal to 180 degrees. So let's draw 3 lines, 3 intersecting lines. There's 1, there's 2, and there's 3. Now you can see that we formed a triangle in the center. And let's actually call this point point A. Now, what we see here is the same thing that we saw in the beginning of the video. We have a line, a point that is not on the line. So, given the parallel postulate, we have that there exists exactly one line that cuts through A that will be parallel to this line right here. Now, we also see that this line, maybe we should label it line A, line B, line C. Now line C cuts through both A and B. We just learned that this angle is equal to this angle, and that this angle is equal to this angle, as long as line C is intersecting 2 parallel lines. Now, one important thing to note here is that these 3 angles, which we'll name A, B, C, add up to 180 degrees. Why? Because they form a straight angle, which is equal to 180 degrees. Now, if this angle is C, and this is equal to or congruent to C, then this is also C. Similarly, this would also be A. What can we get from this? We see that the angles inside the triangle is A, B, and C. We add them together, A plus B plus C. And what does that give us? From here, we see that A plus B plus C in the straight line gives us 180 degrees. Similarly, A plus B plus C here will give us 180 degrees. And that is why the sum of the interior angles of a triangle is equal to 180 degrees. Okay, so in this video, we covered a little fewer things than we did last video, but we went into more depth. Understanding why, or rather how the angles work with each other, and how parallel lines, everything in general just come together, allows us to form really beautiful proofs like this. Now, this is a very simple proof, yet it's very satisfying and it works out very well. Usually in school, perhaps you will learn just that the inside equals 180, but by being able to prove this, it will give you a better understanding of triangles, lines, and angles in general. All right, so that is it for this video, and we'll see you in the next one.